In this video, we're going to talk about how we write functions and an important thing called function notation. So here's just some vocabularies. Independent is like our input. It's the value we plug in. Dependent is the output. Basically, it depends on whatever we plug in. A function rule is just something we have to follow. Basically, it's an equation. That's how we write a function rule. It looks like an equation. And function notation then looks like f of x, and that's how we read it, f of x. It doesn't mean f times x. It's just a way to give an equation a name. Just like people have names to tell us apart, equations have names as well. So here we're going to use a table to write an equation in function notation. Again, we have to first identify a pattern and then try to write an algebraic equation. So we have a set of ordered pairs that we've written in terms of a table. And so we just figure out how to get from x to y. So we could try a couple different things. We could add 2. We could multiply by 3. But we have to identify the pattern that's happening every time. So if we notice here, every time we are multiplying by 3. So this is our pattern or our relationship because it works for all the values, okay? We're multiplying by 3. And so now we just write that in terms of an equation, okay? So the way we write that is we take our x and we multiply it by 3. So we take x and then we multiply by 3. And that's going to give us those y values. And so a prettier or a more common way to write this would be 3 times x equals y, or y equals 3x. And then if we want to write this in function notation, we just take the y and we replace it with an f of x. So f of x equals 3 times x. And this is just the prettiest way to write this. The other two are also correct. So now we're going to evaluate the function for the given input values. So this is our equation. Remember, f of x just means y. So it's just like y equals 3x plus 2. Nothing different. It just looks different. Find f of x, or find y, if x equals 7, and then again if x equals -4. So first of all, we're going to use x to be 7. So we're going to say, we're going to take the function f, and we're going to replace the x with a 7. And then our equals drops down. And then on the right-hand side, we're going to do exactly the same thing, only we're actually going to replace that x with a 7. So all we did is replace each of these x's with 7s. And remember, this is just a name, so it's going to drop down. And we're only going to evaluate the right-hand side. So 3 times 7 makes 21. And 21 plus 2 makes 23. The name f of 7 drops down, and it's just a more descriptive way of saying that y is 23. I guess we should finish this example too. Let's go ahead now, and we're going to try -4. So we're going to take f, same thing that we just did, taking this equation up here that I just cleaned up a bit. And this time, though, we're going to plug in -4. And so now we're just using this same equation. We're going to take 3 times whatever we're using in place of x plus 2. And again, this time we're plugging in -4. This on the left-hand side is just me saying I'm going to plug in -4. On the right-hand side is me actually plugging it in. So again, on this side, 3 times -4 makes -12. Going to drop down my plus 2. -12 plus 2 makes -10. And again, this is just the label. Okay, and this is how I write my answer. It's the same thing as saying that y equals -10, but this is just more descriptive. It tells me which equation I used, and it tells me what I plugged in to get my y value. Now we're going to find a reasonable domain and range. Again, domain is the set of all of my x's, and range is the set of all of my y's. Domain is also called my input. Basically, what numbers make sense to plug in? What numbers can we plug in? So Joe has enough money to buy 1, 2, or 3 DVDs at $15 each if he buys any at all. Write a function to describe the situation and find the reasonable domain and range of this function. So first of all, we can't buy half of a DVD, right? So this is my input. This is me saying I can buy 1 DVD, 2 DVD, 3, 4, and so forth. I can't buy a half of a DVD, or I can't buy negative DVDs. If I buy 1, that's going to be $15. If I buy 2, that's going to be $30. 3 would be $45, and 4 would be $60. That's just because they're $15 each. So the question is now, we need to first write a function to describe the situation. So the function is, how do we get from x to y? And if we identify the pattern here, we're multiplying by 15 each time. So we're starting with x, we're multiplying that number by 15, and that's giving me my y value, or my output. Remember, a prettier way to write this is to start with f of x, and instead of writing x times 15, we usually write this as 15x. And this is the function to represent the situation. The reasonable domain, again, domain, what numbers can we plug in? We can't use negative numbers, we can't use decimals. So we'll say we could buy 1 DVD, 2 DVDs, 3 DVDs, and so on. We could technically buy 1,000,000 DVDs, so that number can keep going. And then my range are all my outputs. Again, we can't buy half of a DVD, so we can't spend increments that are not exactly increments of 15. So we could spend 15, we could spend 30, we can spend 45, and so forth. Technically, here in this situation, we could buy 0 DVDs and spend 0, but the situation said 1, 2, or 3, so that's why we're starting with 1. So here's just our key ideas. F of x and y are the same exact thing. F of x is exactly the same as writing y. F of x is just more descriptive. And then just, these are lots of different words to call our x values, and these are a bunch of words to call the y values.